Buying a house is a dream for many, and they plan many years to buy a house. So predicting the selling price of a house will be really useful for those buyers. So in this project, we have taken a community near yourself and tried to predict the house prices in that community. I'm Nehid and I'm going to explain you the initial steps we have taken, like the data analysis we have done to predict the selling price of a house using machine learning algorithms. So initially we have considered the features of the house, such as the number of bedrooms it has, the number of baths, the type of baths, how many car garages it has, and also features like the list price of the house when it was listed for selling and when it was listed, etc. And predicting house price is not only important for buyers, but it's also important for real estate developers who can price it correctly, and also for the banks who give loans for it. So initially we performed feature engineering of the variables such as baths, where a single bath is taken as 1 and a half bath is taken as 0.5 and create a new variable called baths. And also if it's a special sale, it is 1, otherwise it is 0. So one hot coding was performed for also a roof based on the type of roof and the type of pool. And also year was extracted from the date column to help in prediction. And after feature engineering, we had tried to visualize the variables, and the dependent variable is visualized using histogram. As we can see, it is heavily tried, so log was applied, and again a histogram was drawn, and it is seen that it's normally distributed. So this information we have used while creating the models. And also we have performed exploratory analysis on the various predictor variables to see if there are any missing values, and we have dropped them accordingly. And also we have done the heat map of the various variables to see if there is any collinearity or correlation between variables, and the collinear variables were dropped. And after this analysis, we narrowed down to these variables which can be used for prediction. And also to see how these variables vary with the dependent variables, that variable that is price sold, we have done pre-plot of the continuous variables and see that all the variables vary linearly. So we have not considered any polynomial or exponential variation of the predictor variables. And the process used to build them.
Hi, I'm Sai. I'm going to explain the steps that we followed to build this model. The initial step is the data collection. For that, we've used home sales data. And then we did some exploratory analysis to identify patterns or any anomalies that we have in the data set. And then the third step is feature engineering, where we've selected the variables that are most important for building our models. And then we've did some data visualization, as Nihit has already explained in the previous slides. And then for the fifth step is the data pre-processing. For that, we've initially split the data into train and test splits. We have selected 70% of our data for training it, and then 30% to test it. And then we've used string indexer, and some of the columns are categorical columns to convert them into numerical data. We've used the string indexer to convert these columns, and then we've used the vector assembler to convert all these columns into features column. And then we've built the pipeline, and that's what we've done in the fifth step. And the models that we've chosen are decision tree regression, random forest regression, generalized linear regression, and linear regression. And training the model, we've trained the models, and then we've evaluated each of the models to identify which model is the most perfect, and which is giving us the better data by comparing each and every model. So the initial model is the decision tree regression, we've run this model and plotted the predicted price and the actual price. So here we can see that we've got root mean square error of around 49,500, and then the R squared is around 0.86, which is relatively considered okay, which 0.86 tells us that there is a good correlation between the predicted value.
Hi, my name is Jekar Rajana. Here I'm going to discuss about the random forest regression model and generalized linear regression model to predict the house price as part of our project. So here is the code for a generalized linear model, which is run on Databricks, where I took log as a link because the histogram of price sold was actually right skewed, which was said earlier. And here I've constructed the uh, generalized linear model, and here is the predicted price and the actual price. So when we see the graph like between price sold and the prediction, it looks pretty decent, but the AIC value is pretty high. So and then going to the random forest model. Here's the random forest model, where I've constructed the random forest model here, and here are the results where the predicted value is this and the actual value is this. So and here's the plot between the price sold and the predicted value using random forest regression. So here's the RMSE value, which is the root mean squared error, which is 40,730, which is used to evaluate the performance when compared to other models. And this is the R square value, which is 0.9, which is actually pretty good value as it is close to 1. So here on we see the further models and go to the conclusion.
Hello, my name is Sharani, and I'm going to explain our next model in predicting the house sales price, which is the linear regression model. So we have built a linear regression model to drive our analysis and prediction on the house sales price. From the model metrics here, we can see that the RMSE of the trained data set is 21,000 and the R square of the trained data set is 98%. The RMSE of the test data set is 18% and the R square of the test data set is 98%, which signifies that the model fits the data well and 98% of the variance in the data can be explained by the model. Also, from the below visualization, we can see the predicted values of the house sales price versus the actual house sales price, which gives us an idea that it is following a linear pattern and the linear regression model fits the data. Coming to the various predictors, their coefficient and their effect on the house price, we can see which variables among square feet, tile roof, pool, beds, baths and others have a strong effect and which ones have a weaker effect on the house price. Also, we can assess which variables would ideally increase the house price and which would ideally decrease. This is very important in complete analysis and predictions and helps us in having a fair idea of the probable effects of the predictor variables. We have built a similar linear regression model in R and have done some comparative analysis on the effects of the predictor variables with our linear regression model. So here we come to the conclusion of our project, where we have gone through the process of exploratory data analysis, feature engineering, data visualization, data pre-processing, and finally build and evaluate our models. Among all the models built, the linear regression model is performing the best and is able to explain the highest percentage of variance in data, as we have already seen. From the coefficients of the model, we can assess which factors influence house price and by how much. This helps real estate developers to understand in-demand features and factors of a house and plan and construct accordingly. Overall, it was a successful analysis to predict prices of houses. It would help active buyers and investors to take informed decisions. Also, it would be of great value to real estate industry as well as banks. So this brings us to the end of our project. Hope you liked it and thanks for watching from all of us. Thank you.